Thanks for having me. So I'm going to describe some work that I was involved with a few years ago where we were approached by a gentailer to help them investigate the effect of differential pricing for electricity to try and shift load from the peak periods to off-peak. So the aim, as you know, it's very costly for retailers to the peaks that come in residential demand. They pay more from the suppliers for at those times, so they lose money. So a big focus for a lot of electricity retailers is trying to shift that peak. And the theory behind it was quite simple economics, to make it more expensive for individual household consumers for their electricity at peak times, which is defined from 7 a.m. to 7 p.m. Monday to Friday. So to make electricity more expensive at those times and less expensive at off-peak times. So Homo economicus. And relatively old. The trial ran from August to July 2008 to 2009. So I analysed these data a few years ago, so my memory's a bit hazy. I'm happy to take questions on points of clarification during the presentation. I'll try and answer big picture questions later on, but maybe I don't remember the answers. So we recruited about 400 people, but inevitably we ended up with usable data for fewer than that. But we ended up with roughly 80 people in each group. So classic experimental design, where we had a treatment group, 4 different treatments, and then a control group. So all the groups received information about how to reduce their energy usage overall, so general energy conservation tips or electricity conservation tips, and they also, as well as the price signal. So one group was a kind of a baseline group, they just got the information. Another group got a low price differential of just a 4-cent price difference between the peak and the off-peak rate. Other group had a medium difference, and another group a high price differential. And we asked our client for a control group, a true control group of people who are totally unaware of the trial, but for some reason they only gave us data on 55 households. So the data are actually smart meter data of readings kilowatt hour at half-hourly intervals. So that's the response variable that we're dealing with. In the interest of time, I'll skip over the sample description. There's a suburb in Auckland which is a bit older, a bit whiter, and a bit more wealthy than the average New Zealand household, but our client tells us that the sample is actually quite demographically representative of their customers in that particular suburb. So yeah, I'll just skip over that.
The age of the houses or the age of people?
Younger houses, older people, yes.
50-54 is people, not houses.
Yes. Yeah. Yeah, so I'll skip over that. So this is the kind of information or the data that we're analysing. So it runs from, what I'm showing you here, runs from January 2008 to July 2009. So this is the proportion of off-peak use. So the average somewhere around 47%, say. So this is average over all the households in the experiment over time. Well, it's actually median, not mean. And you'll see there's a few big changes there. So these are the things to be expected. There are things like Waitangi Day, Easter, Anzac Day, where pretty much everyone goes away for the weekend, and so that power usage, electricity usage, sorry, drops during those periods. So that was our basic response variable of interest. But also, since people were provided with information on conservation as well as load shifting, we're also interested in total electricity usage. So I'm sure many of you in this room have seen graphs like this before, again running from January 2008 to July 2009. We were showing strong seasonal variation. So that's electricity usage goes up in winter and down in summer, surprise, surprise. Everyone's familiar with this. From an analytical point of view, it introduces a few, or an additional kind of noise factor that we have to deal with, I suppose.
So those are kilowatt hours a day, are they?
Median kilowatt hours per day, I think. Okay. can't remember. Yeah. So, yeah, breaking that down, so we looked at, so that's average over all the households, and so then we broke it down to our control group and the various experimental groups. So you can see there's a clear difference between, there seems to be a definite group effect there. There's one group up in the middle, a couple sort of bunched together in between that, and then a couple down have lower usage. Now something momentous happened around there. So that's around the start of August 2008. So can you see any difference in pattern between what happened before there and what after there? I can't really see any difference, and there is no difference. But the momentous event that happened then is that's when the trial started. So our client claimed to have allocated these households randomly to experimental groups, but maybe they did, maybe the random number generator just came up with an incredibly unlikely statistical fluke. But what actually happened was that there is a clear difference between the experimental groups before the treatment was applied, before the price signal was applied.
There's an evidence difference in slope on the up and down, and that slope of the down is probably half again as steep as the slope on the up.
So that's just winter.
Visually,
Yeah. So that's just winter. Yeah.
clear difference.
Yeah. Oh, so you're saying that slope is steeper than this slope? Is that what you're saying?
That slope is less steep. The slope down is steep.
Yeah. So that's just the general winter seasonal effect. Okay. So it was quite tricky dealing with this, trying to partial out the effect of the pre-existing differences to see if there was any effect of the actual price signals. So another thing which is looking at averages really hides is the absolutely huge heterogeneity of individual household demand. So I want to show you an example of that. Just to be clear, so what we're analysing were two sets of analyses: the overall demand, so total kilowatt hours used, but also the proportion used. And we aggregated over monthly periods, because what we're assuming, I suppose, is that people they get their power bills monthly, and so they think back over the past month and say, oh gee, we've been using a lot, we better change our ways, or something like that. As part of the trial, they did get more frequent feedback, but they seemed to be reacting to their monthly bills more than to anything else. So just as an example, so this is a random sample of the 20 households in the trial, ordered by high users to low users. So you see there's a couple of patterns there that look like displaying the average pattern of seasonal variation responding to winter, but there's other patterns in there which don't display much variation at all. So in addition to high use and low use, just the shape of those squiggly lines is very, very different. So there's a lot of individual differences between households, and looking at averages masks a lot of that. So what we tried to do is to figure out, well, what are all the things that could have influenced people's overall use and also the proportion of electricity used at peak times. So what we were really interested in is the experimental group, so that was obviously a variable that we put in there. But if you want to build a good explanatory model, you should include everything which might influence things. So you can then isolate out the individual effect of your variable of interest, I suppose. So we included time, of course, seasonality to take care of that. Also the pricing plan, some people were on where they paid not only did they pay a different price for their variable costs, but they also had a different ratio of fixed to variable costs. Some people would pay a higher fixed cost trade off for a lower variable cost. And then the added complexity was then they would be in one of the high, medium or low groups. Characteristics of the house, floor area, age of the house, so on. Method of hot water heating, which turned out to be a big explanatory variable. Also the household, so the number of people, whether there was anyone in the house who had special needs with respect to electricity and so on. And then the householder, the individual respondent who we surveyed them before, during and after the trial. in particular values regarding the environment and research use.
Did they have other space heating? Yeah, people had gas heating?
Yeah, heaps of that. Space and water heating, yeah.
And you reported that.
Yes, yeah, so we've got all that. Where are we? Yep. So basically we threw everything we could think of into the model that might make a difference. So time, so seasonality, as we know just by looking at the graph. The method, the pricing plan that they're on, so the ratio of fixed to variable costs, this is explaining total use. The method of heating hot water, specifically whether they use electricity or not electricity to heat water. Floor area of the house, whether they had someone who had special needs. If anyone's familiar with a scale called the New Environmental Paradigm, it's a bunch of about 5 or 6 questions which are supposed to relate to environmental values. One of them was the level of agreement with the statement, the Earth is like a spaceship with limited resources and we have to manage them effectively. So people who agreed more with that conserved more electricity. But specifically, there's no difference between any of the treatment groups, so the people who had information and a price signal, and the control group, so the people who are totally unaware that the experiment was even going on. And moreover, there's no difference between the treatment group and any other treatment group. So these, those pre-existing differences there, they are due to the pricing plan that people were on, actually, as opposed to the price differential signal that they got. So it was, from our point of view, it was an extremely disappointing outcome. So explain total use. What about proportion of electricity used at peak versus off-peak time? So the outcome, the measure of interest was the proportion, so the proportion at off-peak as a proportion of total use. So the same explanatory variables were thrown into our model as for explaining total use. And much the same, similar ones came out significant, so time, seasonality, the pricing plan income turns out to be significant, and number of hours spent at home, which you'd think would make sense. So no actual surprises there, all seems to make intuitive sense, but to our clients' dismay, there was no difference between the control group and any other treatment group, or between any treatment group and any other. I'll skip over this. For those of you, if anyone's familiar with the concept of goodness of fit, when looking at trying to explain differences within households, so what affects usage over time, we're quite successful in explaining that, but looking at explaining the differences between households, why one household uses more or less electricity or more or less at peak versus off-peak time, it had some absolutely miserable goodnesses of fit. Something, again, which we're quite unhappy about. We actually wanted to go back and reanalyse these data, but the client wasn't really willing to pay for it. So that kind of went to the bottom of our to-do pile. We also did a post-trial survey and look at, so these are self-reports about people's experience of the trial. And this is the percentage of people who actually followed the advice that they were given them. So tried to conserve electricity. So this is more about conservation versus load shifting. So installed insulation, so these are the percentages of people who said they did something. Huge amount of people said they changed the time of use, and including things you'd think would make a difference. But it turned out that they didn't. So maybe this is a problem of self-reports, or maybe it's a problem of just looking at averages and not looking at individuals in sufficient depth. What else about just attitude, so actually being in the trial itself? So this is the self-reports of being homo economicus, more or less. So the percentage of people, so over half the people agreed that the difference in prices was an incentive to change. So they thought that, but they didn't quite act that way.
No, you actually did.
Yeah. And only a few people thought that it was too much trouble to change. And most people thought it was actually easy to take advantage of the price differential.
That's the second contradict, don't
Yeah, they do a bit.
They're not self-reporting.
Yeah, so not only not homo economicus, but not internally consistent. And I should stop saying they when I say these things. I think these things about myself often, several times a day, in fact. People liked being in the trial. They really, really liked it, and they wanted the retailer to offer the product. They wanted them to launch it as an actual option for them when they were signing up for electricity in their home. And I don't think they have yet, but as far as I can gather, it's coming. Time of use pricing is coming. Lots have changed, so self-reports have changed, but unfortunately the price signals didn't really have an effect. On average, on aggregate. So what we suspect is some people did actually make savings, but they were offset, the other side of the average, by the Jevons paradox. Right, okay, so that's all I have to say to you. Now you can have lunch.